to help explain this to both you and to me. So I've got a weight here, and that weight, so 75 kilograms, and it is falling into a basin of water. Now, the distance that it is falling is 1.50 meters. And it is going into that basin of water here. And that basin of water has 200 mLs, which, if we remember water, means it's also got 200 grams. And this is for water. And it wants to know how much would the temperature change. Okay, so basically what we're dealing with here is we are dealing with two things. Okay, we are dealing with the weight falling and the water here. Now, since it is asking for the temperature of water, then that means we are probably going to end with the water step. Also, we have the weight, the height, and gravity right here, which will be able to get us everything we need for the weight. So, for the weight, what we need to focus on is we need to focus on these hints. We need to focus on this hint and this hint for the weight. Okay, so first off, the gravity, I'm just going to need this. I'm going to put this in a nice little pink box because I'm going to need this. Our definition of a joule is what is important to start. A joule is equal to kilogram times meter squared over second squared. And I just realized I did not make that smaller. Let's try that again so that's less sloppy. A joule is kilogram times meter squared over second squared. So if we build these units, we're going to get a joule. Well, we've got kilograms of the weight. We've got that 75 kilograms for the weight. So there's my kg. I then have my meters that it fell times 1.5 meters. That's one of my meters. And then I've got my gravity, which is 9.80 meters per second squared. So as you see here, I've got kilograms, 1 meter, 2 meter, over 2 seconds. So all of this together is going to equal joules. This here is going to give me the joules. It's going to give me how much energy that weight put into the water. So 75 times 1.5 times 9.8. Now I do not want to lower this yet, so that's 110, no, sorry, sig dig. I don't want to sig dig this yet. 0.5 joules. Okay? So the reason that is important, and why we did that first, is this joules right here. This joules was put into the water, which means this same number, 110.2.5 joules, is going into the water from the weight. Which means if I want to find the temp change of the water, that means I've got my whole thing of, you know, my delta H equals MCAT. But what I want is the delta T by itself. So what I need to do is I need to take my M and my C and push it to the other side where my delta H is. M times C. So there's the formula I'm going to use. which means this is my delta T. My C is 4.184 because it's water. And my mass is this 200 grams here, you know, because this is the mass of water. So 200. Now remember, I've got math under a line, so I want to stick that in parentheses. But that's going to give me my answer. See, I needed to calculate the weight in order to find the energy so that I could find out the temperature change of the water, because the energies would be the same. In reality, the energies would not be the same because of the second law, but we're not calculating that. That's like an upper end college thing. We're not going to deal with that right now. So our final answer of what that temperature change is going to be in 3 significant digits, 1.32 degrees Celsius. So there you go. That is our advanced calorimetry, how we had the energy from the weight goes into the water. So we calculate out the energy from the weight. We use that for the energy of the water. And then we do our delta H MCAT to determine our temperature change. Just like that.